guys, welcome to Moral's Math Corner. Today we're going to be talking about surface area of circular solids. Now the good news is that there are no new formulas to learn for the surface area of a circular solid, such as a cylinder. A cylinder, although it's not by definition a prism, because I don't have two bases that are polygons, I do have two congruent circles as the base and the top. So even though it's not a prism, we can use the formula of the prism, which is 2 times base area plus base perimeter times height. Now, in this particular case, since we're talking about a cylinder, the base area is the pi r squared. So 2 times pi r squared, because I have the top, and then I have the base. Okay, so that's why I have 2 times base area, just like a regular prism, plus perimeter of the base times the height. Well, in this particular case, perimeter of a circle is called circumference. So that's 2 pi r times the height. Now, very simple to understand this, but I want to break this down for you guys so you could really understand where it's coming from and why these formulas are valid, and this will hopefully help you out forever with cylinders. When we're talking about a cylinder, think about this. You've got the top, which I can pop off as a circle. I've got the bottom, the base, that I can pop off as a circle. That's where your 2 pi r squared originate from. Does that make sense? Now, the actual lateral area, this part of it, okay, the lateral area, if you unfold that, you make it a flat rectangle. Now, the area of a rectangle is, of course, base times height. Well, in this particular case, what would your base be? Well, 2 pi r, exactly, it's the circumference. Isn't the circumference the distance around the circle? So, if the distance around this circle is the circumference, isn't that the base of the rectangle that we form after we unroll the cylinder? Now, you can't see this out in the internet, but basically it's this. Take a circle, make like a little telescope. Okay, you can see, everyone's there seeing that. You cap the bottom and the top with a circle. Pop those circles off, and now you have these 2 circles that I'm talking about. You with me? Now, take this paper and flatten it out. Does it not become this rectangle? So that's where the formula comes from. That's how it originates. Does that make sense, guys? So you can really understand and picture this now? Excellent. Thank you. Okay. Now, new formula. Here, unfortunately, we have no choice in the matter. This is a cone, okay, a cone. Kind of like the ice cream cones that you guys eat, a cone on the street, those Bob's Barricade cones. Okay, it's a cone. It's not a triangle. It's got a circular base, and it points up, has a peak, has a vertex. Now, the surface area of a cone is pi r squared, because that is the base. It's the base, pi r squared, okay, plus pi r times sh. Underneath that, I put it into words. It's really the base area plus half of the circumference times the slant height. But since circumference equals 2 pi r, what's half of 2 pi r? Pi r. So that's why you get the pi r times slant height. To find the slant height, notice here, my friends, that the slant height is basically the hypotenuse of the altitude of the cone and the 90-degree intersection, the perpendicular intersection of its radius. Well, you just use the Pythagorean theorem to find any of those. To find sh in particular, it's the square root of r squared plus h squared. But remember, this is just derived from slant height squared equals radius squared plus height squared. But then when you take the square root of that, slant height equals the square root of r squared plus h squared. I just wanted you to know where that came from. Okay? So that's cone. So far, even though we can find the surface area of a lot of figures, we've only learned 3 formulas. Surface area of a prism or cylinder, 2 times base area plus base perimeter times height. Pyramid, base area plus lateral area, which is the individual face areas all added together. Third formula, cone, pi r squared, base, times pi r times slant height, or base times 1/2 of circumference times the slant height. Very simple. Please be aware that whenever you have the cone, you're going to be working with 3 values. The slant height, the height of the figure, and then the radius. Please be careful. Remember, the h is the height of the polyhedron, the height of the actual figure. Does that make sense, gentlemen? Last formula for, last formula for this section. Sphere. Sphere is the easy one. It's 4 times pi r squared. Now, a lot of times people don't understand why it is 4 times pi r squared. Well, hopefully I can help you out. If you think about what a circle is, okay? Circle, bear with my drawing, composed of that guy, and that guy. Does that look very loosely, but kind of like a basketball with those lines going all over the place? A sphere is made up of 4 circles. So therefore, the surface area, pi r squared times 4. Now, my last class, someone said, wait, aren't there really infinite number of circles in the sphere? Yes. What we get this formula from is not the possible number of circles in there, but the base number of circles. It's kind of like the skeleton of a house, like the frame of a house. Okay, if I were to get rid of these drywalls here, every 16 inches, I'm going to have a straight 2x6, or maybe even a metal 2x6, and it's called a stud. That holds the walls up, okay? But when you see this wall, do you see those studs? No. So when you see this sphere, you're not going to see the circles that made it up, but there are 4 circles which make up a sphere. And the surface area of a sphere, very simple, 4 times pi r squared. Let's do some examples, and then I'll show you the easiest chapter of your life, which is 12.5. Okay, 12.4, I apologize. So let's find the total surface area for each figure. Okay, let's not make this a mountain out of a molehill. Surface area, this is the surface area, it's just like a prism. 2 times base area plus perimeter, base perimeter, times height. Okay, so in this case it's going to be 2 times pi r squared, which is going to be 25 pi, excellent, plus base perimeter, 10 pi, times height. So in total, this is 50 pi plus 60 pi, so that's 110 pi square units. Please always put the units, please, area is always squared. Let's look at B. In this case, the surface area formula here is the base area plus 1/2 of circumference times slant height. So what is my base area here, gentlemen? 25 pi. Awesome. Now, half of circumference It's basically it's going to be pi r. So plus 5 pi, thank you, times slant height of thank you. So this is going to be 55 pi units squared. Does that make sense? Sphere, easy. Surface area of a sphere is 4 times pi r squared. So in this case, it'd be 100 pi without even batting an eye. Excellent. Okay? Now, I know that you guys always say, oh, it's always so easy here, but then on the homework it's hard. No, it's not. You just got to use your brain. But I'm going to give you an example of what you may be seeing on the homework, okay? So that everyone can understand what's going on. May I? Yes, yes, sir? Come again, sir? No, I'm not going to scroll up because it's on video. But sorry, my man. Okay, now, I have, yeah, like an ice cream cone. I want to find the total area for this as well. Okay, so let's think about what this is made up of, guys. Thank you. You have a half a sphere, very good, and a cone. Now, thank you. That is thinking. I was just told this is an ice cream cone without a base. Yes. The actual surface of this that belongs to the cone, is that inside the figure or on the outside of the figure? So are we going to include that in our surface area? So to make our lives easy, surface area of the cone, remember, is the base plus half of the circumference times slant height. But for this particular case, get rid of the base. Excellent, guys. So the surface area is going to be 1/2 of the circumference. Well, isn't the radius 150? Right? So 150, so it's actually going to be, but divided by 2 is going to be 150, right? So that's 150 pi. Now, slant height. If this is 150 and this is 200, what is my slant height? Okay, guys, remember that slant height is going to be this. It's a 345 times. It's a 345 times. It's a 345 times 50. Yes. So what would this hypotenuse be? 250. So now I got it. That's my base area right here. I mean my half of the circumference times 250. So what would my giant number be? Leave it in terms of pi unless I tell you, please. So 150 times 250, we're going to get 37,500 pi units squared. So just be very cognizant. Is it inside or outside? If it's outside, it's part of my surface area. If it's inside, I got to subtract it. Now, you could have found the original surface area and then subtracted this base. You could have, but that would have been more work. In my opinion, right from the get-go, you can get rid of that. Yes, sir. Okay, yes, hold on. That's just to the cone. Now, we got to do the half sphere, absolutely. So the half sphere is going to be 4 times 150 squared, right? Pi, correct? Divided by 2. So this is going to be 2 times, isn't that 150 squared pi. So you got 2 times 150 squared equals 45 1,000 pi. So in total, my total surface area is going to equal 82,500 pi units squared. Pi stays the same, yeah. Pi is pi. 3.14. Now, if I say to you, or they say to you, or a test says to you, round it to the nearest hundredths or tenths, then you put in your calculator. Okay? Does that make sense?
Perfect sense.
Awesome. Okay. Let's move on now to 12.4. Easy, easy, easy. They love to give you 50 million different formulas for this and really try to confuse you. They really do. There's all sorts of different formulas that they love to try to confuse you with. If you just know how to find the area of a base, I give you my word of honor. Any prism or any cylinder, you can find the volume with this formula right here. It just depends on what the base is. Okay, remember, if the base is a hexagon, remember, 1/2 of apothem times perimeter is the base area for that. So I have to find the apothem, the perimeter, get the base area, 2 times base area, plus the lateral area. Okay, it's that easy. However, for volume, it's very simple. Base area times height, literally. So the volume here is 100 times 15, 1,500 units cubed. Because remember that I said that area was how many square units are in a figure, right? Well, in this particular case, it's how many cubes. How many equal cubes are in one figure? It's how many congruent cubes are inside the figure. Remember, area is how many square units in a figure. Volume has 3 dimensions. Volume is a capacity. It's like cups and ounces, fluid ounces, gallons, that's all capacity, volume. Yes, sir? Yes, sir. Yes, sir. The question was, when back in the day in elementary or middle school, they would give you little cubes and you put the cubes inside and figure out how many cubes fit inside of here. Yes, you were finding volume 100%, sir. Okay? Does that make sense? So like for cars, okay, I'm a big on space for cars. I do a lot of outdoor stuff. I always look for the cubic volume, the volume of the car. Okay, the volume tells you a lot. Some cars are really small, but they have a lot of volume because they have very ergonomic space inside. So volume is how many equal congruent number of cubes can I put inside of a figure. Let us continue. All right, I want to find the volume of this triangular prism. Well, volume equals base area times height. The base area here, well, I'm going to cut this down here in half with an altitude. So this is a blank, blank, blank. 3, 4, 5 times 2, so that's 8. So my base area is 12 times 8 divided by 2, so that's 48, right? Times my height of 15. Remember, the height of the polyhedron is from base to base, not the height of the base itself. So that's going to be times 15, correct? And then that's going to be 720 units cubed because it's volume. Does that make sense? Just out of curiosity, just for giggles, if I say what's the surface area of this bad boy? It'd be 2 times base area plus perimeter times height, which is lateral area. So what's the base area again here? So 48 times 2 is 96. Plus, what's the perimeter of that base? 32 times the height, 15. So what would this surface area equal? 576 units squared. Know the difference, boys? Please? Okay? Great job, great job. And be aware of if it's volume or surface area. Let me pause for 1 second. Okay, so we have finished this problem. Let's move on to the third. Let's find the volume of this cylinder. Same thing. It just doesn't change, guys. Volume equals base area times height. What's the base area here? 9 pi times the height of 12. So that's 108 pi units cubed. That's it. It's volume. Told you it was a very simple chapter. And last but not least, okay, now this is a good one. Let me bring this up a little bit. The way I built this, I think you guys are going to appreciate the way I built this. I did this on purpose so you could really see what's going on here, okay? In this case, guys, we do have a volume that we're going to be able to calculate here. But there's a little bit of a problem here. If we were doing surface area, everything would be calculated except, wouldn't the inside here have to be subtracted? Right? We're all there, right, guys? You promise? Okay. Because it's on the inside. Very good, son. God bless you. Now, is that going to be the same for volume, which is an inside measure? No. So, check out what I do. You're not going to be able to do this, what I'm doing, of course, because you can't do this on your paper. But just envision what I'm going to be doing now manually. If I just separate the two, okay? If I separate the two here, okay? You see what I did here? Actually, we had it right. It was like right there. Okay? Does that make sense so far, guys? Okay. Now let me make sure that I have all the. I think I'm missing one value, but if not, we'll figure that out. No. Yep. Okay, we're perfect. Okay, so let's think about this. What is the volume of this guy? First start here. Now you're not missing a number. Is this guy 10? Okay, look. Yeah, it does. Because we have here, yeah, we have 2, 5, and 10. Okay, and actually, wait, yeah, I did mess this up a little bit though. Hold on. No. Let me show you. I know what I did. It's this guy. This guy goes here. My bad. Completely my bad. There's no excuse there. I'm sorry. Let's get rid of this for a second. Let's connect these guys again. Okay, so sorry about that. Okay, so again, you have this here. Separate them. Now the volume of this guy, remember that's 10. So the volume here is base area times height. Well, base area, 50 or 20 times 5, either way, 100 units cubed. Then what's the volume of this guy? 70 times 4 or 40 times 7, 280 units squared. So what is my total volume? Yes, that is cubed. Sorry, son. Thank you. So this is going to be 380 units cubed. And that's it. That's what I'm looking for. Yes, sir. I'm sorry, son? Okay, the question is, how can I say that this is 10? Okay, when I put them back together, this width is the same as this width, man. What do you mean, why? It's sitting on top and it's the exact same distance. It looks smaller because it's hard for me to draw this, but this and this are the same exact distance. It's the same exact distance. Think about it. Look, this goes down here like this. This goes here like this. This guy's the same as this guy, and this guy's the same as that guy. It just looks weird. I did the best that I could for my drawing, but it is you. If you look at it in your book, they do a perfect job of drawing it. You know, I'm human, so I could only draw it as best as I could. But this is the same as this. It's the same as that. Does that make sense? Thank you very much. Have a great day. God bless you all. Thank you. Thank you.